Welcome to helpyourmath.com. In this video, we're going to look at writing equations of functions based on the graphs of absolute value functions, and we're also going to graph some absolute value functions based on the equations that we're given. Okay, so first we want to write the equation of the graph shown. Now we know that the parent function here is f of x equals the absolute value of x. And we know that any transformations, if we're going to write it in function form, we would say a times x minus h inside the absolute value plus k. And what we know is that the vertex of the graph is given by the coordinates h comma k, and a tells us two things. It tells us whether the graph opens up or down based on whether it's positive or negative, and it also tells us if there's a stretch or a shrink, and there would be a stretch if the absolute value of a, so just looking at the value instead of the sign of it, is bigger than 1, and there's a shrink if the absolute value of a is less than 1. And if a equals 1, then there's no stretch or shrink. So we want to be able to write the function, the formula for this particular graph. So we know the vertex is right here, and it has the coordinates 2, 4. So we're off to a good start. We can say g of x equals a times the absolute value of x minus 2, right? When it's inside the absolute value, it's the opposite sign. When it's outside, it's the same sign. Now we need to determine whether a is 1 or something else. We know that it's going to be positive because we can see the graph and it's opening up. If you recognize absolute value functions, you might recognize that a equals 1, but let's say you didn't know that. What you would want to do is pick any other point on the graph besides the vertex. So we could go all the way up here if we wanted to. And we're going to use this point. This is 6, 8. And what we do is we plug in 6 for x and 8 for y, and then we clean this up and we get a by itself, and that's going to tell us the value of a. So, or maybe not y, this is g of x. Okay, so we're going to say 8 equals a times the absolute value of 6 minus 2 plus 4. I want to get a by itself. There's a few things I need to do. One thing I can do is I can take away 4 from both sides. And the other thing I can do is work within the absolute value and say, okay, 6 minus 2 is 4, and then the absolute value of 4 is 4. So I can say 4 equals 4a, divide both sides by 4, we end up with a equals 1 as promised. So now we can write this equation as g of x equals the absolute value of x minus 2 plus 4. We don't need to put the 1 in front of the absolute value. You can if you want, but it's simpler to not, and usually simpler is better. So that would be our equation. In this example, we want to identify the vertex up here. And it also appears, while it looks like there's no stretch or shrink, I do notice that this graph is upside down, indicating to me that a is negative. So first we're going to just label our vertex as -3, +1. And we know that the general form for this will be g of x equals a times the absolute value of x minus h plus k. So we're going to fill in what we know. We have g of x equals a times x plus 3 plus 1. And now we want to determine the value of a, so we're going to pick any other point we see. There's a lot of points. I'm going to choose this one here because I like working with zeros. This is the order pair 0, -2. I could have used this 0, I could have used this 0. I had a few options there, but I'm going with 0, -2. I plug 0 in for x, I plug -2 in for g of x, and we determine the value of a. So -2 equals the a times the absolute value of 0 plus 3 plus 1. I'm going to take away 1 from both sides. That's -3 equals, inside the absolute value is 3, and the absolute value of 3 is 3, so this gives me 3a. To get a by itself, I'll divide both sides by 3, and I get a equals -1. So as anticipated, there was no stretch or shrink, but a is negative since the graph is opening down. So the final equation here would be g of x equals negative absolute value of x plus 3 plus 1. Okay, our last graph that we're given, I see the vertex here at 2, -3. And let's locate any other point on the graph. I like finding a 0. We might as well just stick with that 0, -2. That seems to be a popular one, 0, -2. So again, the generic form is g of x equals a times the absolute value of x minus h plus k. We know the coordinates of the vertex are h and k, and then any other point on the graph, so my 0, -2, that's what we would plug in for x and g of x, or if you call it y, you can plug in y. Okay, we're going to do this to figure out the value of a. I can tell that there's going to be a stretch here, or excuse me, a shrink. Maybe we just don't know by how much, so let's find out. So we have -2 equals a times the absolute value. X we're using 0, h is 2, and k is 3. So we get -2, nope, I'm going to add 3 to both sides, that's going to give me +1, equals, 0 minus 2 is -2, the absolute value of -2 is 2, so I get 1 equals 2a, divide both sides by 2, I end up with a equals 1/2. As promised, there is a shrink on this graph, and also it's positive, which it should be because the graph is opening up. So to write our final equation, we get g of x equals 1/2 times the absolute value of x minus 2 minus 3. All right, in our next example, we want to find the vertex, and then we want to sketch the graph. So first thing, let's locate the vertex. Remember, the vertex is going to be here, here. And so the vertex would be, it's x minus 5, so the vertex is 5, 4. And then depending on how you feel about this, so A tells us some things. We know the graph should be opening down, it should be an upside down V, and there's no stretch or shrink. If you feel comfortable doing that, you can just go straight to the vertex, 5, 4, 5, 4 here, and you can just start graphing points. So I know it's negative, and I know that absolute value goes down 1 over 1, down 1 over 1. And the symmetry is nice because I can just keep doing this. If you don't feel comfortable just kind of plotting these points based on information we know, whoops, I missed my target there, you can always create a table of values. And if you're going to create a table of values, I caution you to use really good points. First, we want the vertex to be the middle point. So we know we want 5 in the middle. Second of all, we know that the points surrounding 5 will have the same y value. So 1 before 5 is 4, and 1 after 5 is 6. So these two should have the same f of x value. Oh my goodness, that was terrible. So f of 4 should equal f of 6, which saves us some time, because then you don't have to plug in both. You can pick which one you want to plug in and plug that in. Then we want to go, we always want to do 5 points. So 2 before 5, 2 after 5. I would go 2 away from 5 would be 3 and 7. And again, f of 7 should equal f of 3 thanks to the symmetry of the absolute value graph. So if we plug in 3, f of 3 would give us -3 minus 5 plus 4. 3 minus 5 is -2. And the absolute value of -2 is 2, but then there's that negative in front of it again. So we end up with 2 negative plus 4, which is +2. So both 3 and 7 give us a value of +2. Let's consult on the graph. There's 3, and there it is at 2. There's 7 too. So it worked. Checking 4 and 6, so you can choose either one. We'll use 6 this time, go bigger than 5. We would get negative absolute value of 6 minus 5 plus 4. 6 minus 5 is 1. The absolute value of 1 is 1, but the negative in front means we need to take -1, and -1 plus 4 is 3. So 4 and 6 both give us an output of 3. Verifying this on the graph, there it is, 4, 3, and 6, 3. So it's nice we only have to check half of the points, which does save us some time. And again, you don't have to create the table of values unless your instructor tells you you need to. But if you don't feel comfortable just using the knowledge, create the table of values. Okay, now this example, we want to be really careful when we create our table of values because of the fraction. We don't want to have to graph things that aren't going to be exactly on the grid that's provided. But before we get to that, let's first label our vertex. Our vertex is nice, and it's located at -2, -1. Some things we know about this graph, we know it's opening up, and we know that there is a shrink because a is 1/3. So we have -2, -1 right here. So now we're going to create our table of values, x and f of x, and we're going to do this. We're going to put -2 right there, and that. When we choose these values, like I said, we want to be really careful that we're choosing values that are going to be non-fractional. We want integer values. So what that means is that we want to plug in numbers here that are going to be multiples of 3, because whatever ends up being in that absolute value is going to get divided by 3. So for example, I happen to know that if I put a 1 in for x, 1 plus 2 is 3, which is divisible by 3. So I'm going to put in 1. Now 1 is 3 away from -2. What's 3 away from negative 2 in the other direction, right? If we go over here, if you don't believe me, here's negative 2. 1, 2, 3 is 1. Go 3 the other direction, 1, 2, 3, we're at negative 5. So those would be 2 really good values to choose because we're not going to end up with fractions. And then what else could I plug in here that would be a multiple of 3? Well, the next multiple of 3 after 3 itself is 6. So what would I need for x to be in order for this thing to equal 6? I would need x to be 4. Now we want to relate 4 back to negative 2. 4 is 6 units from negative 2. What's 6 units from negative 2 the other direction, going to the left? That would be negative 8. So I know that f of negative 8 will be the same as f of 4. And I know that f of negative 5 will be the same as f of 1. Again, this is because of the symmetry of the graph. So you can choose which one you want to plug in. If we plug in negative 8, we would get 1/3 times the absolute value of negative 8 plus 2 minus 1. Negative 8 plus 2, this is negative 6. The absolute value of negative 6 is 6. 1/3 of 6, that's like 6 divided by 3, is 2. So we end up with 2 minus 1, which is positive 1. And that means that 4 would also have a value of positive 1. And that should make sense, right? Because if you plugged in 4 here instead, you would get 4 plus 2 is 6, and the absolute value of 6 is the same as the absolute value of negative 6. So that's why the symmetry works really nicely. Okay, now we have to pick between negative 5 and 1. 1 is smaller and positive, so let's go with that. So f of 1, that would be 1/3 times the absolute value of 1 plus 2 minus 1. 1 plus 2 is 3, and the absolute value of 3 is 3. And 1/3 of 3, or 3 divided by 3, is 1. Oh, 1 minus 1 is 0. Oh, we found some intercepts. So we now know the intercepts are negative 5, 0, and 1, 0, thanks to the symmetry. So we're going to graph these points now. Negative 8, positive 1. Negative 5, 0. 1, 0. And 4, 1. We have a nice shrunken graph. And that's it for graphing absolute value functions.